Okay, so this is part two of the video lecture series for analytic geometry regarding lines and the forms of the equation of the line. Okay, so we are actually done with regards to the forms of the equation of the line. The forms of the equation of the line was already discussed in the previous or part one of the video lecture. Okay, so next in our discussion is actually on intersection of lines. Okay, so for the intersection of lines, we consider first the following illustration. Okay, so we have two lines here, and the equation of the lines are expressed in their general forms. So this is line 1 and has the form ax plus by plus c is equal to 0. Line 2 has the form dx plus ey plus f is equal to 0. Now, these two lines are crossing each other at the point intersection with the coordinates a and b. Okay, so what is asked here is to ask the us to determine the intersection of the given lines. So to illustrate the steps in order to get the equation of the line, let's consider the following examples. Okay, so solve for the intersection of the following lines given the two lines: 4x plus 3y minus 1 is equal to 0, 3x minus 2y plus 3 is equal to 0, and number 2, x minus y plus 2 is equal to 0, 2x plus 2y plus 1 is equal to 0. Okay, so to illustrate, let's consider first example number 1. Okay, so for example number 1, we have okay, so the first step in solving for the intersection of the two lines, for example number 1, this is example number 1, 4x plus 3y minus 1 is equal to 0, 3x minus 2y plus 3 is equal to 0. This is the first step in doing the solution. First, we multiply the first equation by 3 on both sides, and that gives us 3 times 4x plus 3y minus 1 is equal to 3 times 0. Then that becomes 12x plus 9y minus 3 is equal to 0. Second step is to multiply the second equation by 4 on both sides, and that gives us this is not actually 4, but instead of 4, we have negative 4. So this becomes negative 4 times 3x, negative 12x, negative 4 times negative 2y. This is positive 8y, negative 4 times positive 3. This becomes negative 12, and of course this is 0. Okay, so kindly correct the typographical error. Multiply the second equation by negative 4 on both sides. Okay, so what is the purpose of multiplying the first equation by 3, and what is the purpose of multiplying the second equation by 4? The overall idea here is the idea of elimination. If you can recall in your basic algebra, the process of solving for linear equations using elimination, what you do in the process of elimination is that you choose any of the two given variables, either x or y, that you want to eliminate. And in order to do that, you have to make the coefficients of that variable equal. So in this example, what is presented in this example is that it was chosen that x would be eliminated. So since the coefficient of x in the first equation is 4, and the coefficient of x in the second equation is 3. So in order to make the coefficients 4 and 3 the same for both equations, we have to look for a multiplier in such a way that the coefficients becomes equal. So the most obvious is of course the lowest possible common factor between 4 and 3 is 12. So to make 4 equal to 12, we have to multiply 4 by 3. Of course, introducing 3 as a multiplication factor means that we're going to multiply 3 to all of the member elements of the first equation. Okay, so next is doing the same for the second equation. We need to multiply we have to make the coefficient of x equal to 12 or negative 12 instead, because later on we will be adding the two equations so that we could eliminate the variable x. So we have to make the coefficient of x positive 12 and the component of x on the second equation as negative 12. Of course, introducing the factor negative 4 in the second equation means that we're going to multiply negative 4 to all of the elements in our given equation, or equation number 2. Okay, so since we have already done the first and second steps, next step is to do the actual elimination process. The elimination process means that we're going to add the resulting two equations. So adding them together, we have 12x minus 12x cancels each other. Next is we have 9y plus 8y gives us 17y. Negative 3 minus 12 gives us negative 15 is equal to 0. Then from here, it is obvious that we can already solve for y, and y is equal to 15 over 17. Now, you might be wondering why is it that we have chosen x instead of y? Actually, it is simply for convenience. We could actually do the elimination process by choosing y as the variable to be eliminated instead of x. But eventually, or you would realize that we will be arriving with the same set of answers for x and y. But just for the sake of argument, if we're going to eliminate y instead of x, you consider first the corresponding coefficients present in the first equation and the second equation in the coefficients of y. So try to notice that the first equation has 3 as the coefficient of y, negative 2 for the second equation. So in order to if we want to eliminate y, what factor can we multiply the first equation in order to make it similar in terms of coefficients of y for the second equation? So between 3 and negative 2, it is obvious that we're going to multiply the first equation by 2 and the second equation by 3. So what happens there is that the coefficient of the term 3y, if we're going to multiply this by 2, becomes 6y. And the term negative 2y, if we're going to multiply this by 3, that becomes negative 6y. And obviously, if we're going to do this similar step as presented here, 6y minus 6y cancels out. Therefore, in that process we already eliminated y instead of x. But of course, I'm simply describing this to you, but perhaps I'll be asking you to do this exercise and proving that the resulting values for x and y would be the same. But that would be later on. Okay, so let's just continue with this process, with this presentation of the examples. Okay, so what we are now on the step that we have already computed for the value for y. So y is equal to 15 over 17. Next step is to solve now for x. Okay, so to solve for the value of x, we could either choose any of the two equations, either 4x plus 3y minus 1, the first equation, or the second equation that we are going to use in order to solve for x by substituting the value of y in that equation. So what is presented here is that the solution goes like that. It was chosen that the second equation that will be used instead of the first equation. Remember, this is the second equation. So it is presented here that we have used the second equation. So in the second equation, we have substituted the value of y, 15 over 17, for solving replacing the value of y as 15 over 17, then solving for x. Okay, so this becomes 3x minus 2 times 15 becomes 30 over 17. Plus, this is actually 3. Okay, so what uh, there is a missing step here. What happens here is that this is actually this 3 here has the denominator 1, and in what was done here is that these two fractions 30 over 17 was added together and separated into two separate fractions. Adding them together means that we're going to have 17 as the common denominator. So the common denominator is 17. 17 divided by 17 is 1. 1 times 30 gives us 30. Plus 17 as the common denominator divided by 1 is 17 times 3 gives us 51. Okay, so what happens here is that 51 over 17 was found by adding these two together to form one fraction. Then the fraction was separated into two. But actually, the solution here is actually misleading. We could actually have this as simply negative 30 plus 51 over 17. Okay, so let me repeat that. We could actually write this two fractions as negative 30 plus 51 all over 17. So what happens now is that we have simply 51 minus 30 gives us 21 over 17. Of course, transposing negative 21 to the other side over 17 over to the other side gives us negative 21 over 17. Then dividing both sides by 3, and of course 21 is 7 times 3, so you could cancel one of the 3's, both of the 3's, and what is left in the numerator for 21 is only 7. So x equals negative 7 over 17. Okay, so what we have done here is that we have already solved for the value of x and the value for y. So the value for x, that what we have solved as the value for x and the value for y, would serve as the intersection of the two lines, 4x plus 3y minus 1, 3x minus 2y plus 3, and what we have solved is the point of intersection of the two lines. Okay, so this is the point of intersection. Okay, so let's do example number 2. Example number 2, we have the first equation as x minus y plus 2 is equal to 0. The second equation is 2x plus 2y plus 1 is equal to 0. Okay, so in the first step of this solution is that we have rewrote the first equation in the form of x is equal to y minus 2. Now, what is the idea of the solution here is that instead of using elimination, the solution is actually using the method of substitution. Okay, so I am assuming that you already know these methods. These methods are called solutions to linear equations, and these solutions to linear equations are basic or elementary topics in your algebra. Okay, so again, the idea for substitution is to represent one of the given variable in terms of the other. So what was done here is that we have represented y in terms of x. So x is actually equal to y minus 2. So we expressed y in terms of x. Okay, so let me rephrase that. Let me correct that. What we have done here is that we represented x in terms of y. No, not y in terms of x, but x in terms of y. So x is equal to y minus 2. Okay, so the idea of substitution is that once we have represented x in terms of y, we are going to replace x in our second equation. So what we have done here is that the position for x becomes y minus 2. Okay, so distributing 2 to y minus 2, this becomes 2y minus 4 plus 2y plus 1 is equal to 0. Now 2y plus 2y becomes 4y, negative 4 plus 1 becomes negative 3, is equal to 0. Transposing negative 3 to the other side becomes positive 3, and dividing both sides by 4, y gives us is given as 3 over 4. Now, once we are done with solving for y, we can actually go back to our representation in the first equation and substitute the value 3 over 4 in the position for y. Of course, what is left here is that we have 3 over 4 minus 2. So doing that, we have 3 over 4 minus 2. 3 over 4 minus 2 becomes negative 5 over 4. How did it become negative 5 over 4? Of course, this is addition of fraction. This becomes 4 times 2, 8 over 4. So you have 3 minus 8 gives you negative 5 over 4. And of course, the resulting pair would be the point of intersection between the two lines. Okay, so this would be the end of the topic discussion on lines and the intersection of lines. I will be giving you one set of exercise on this topic, and I'll be expecting your solution for this tomorrow. The submission will be tomorrow, Friday, April 29.